Alrighty, so these are your multiplying and dividing rational expression notes. And just a quick note on these, it says assume all expressions are defined. And what that means is that we don't have to worry about identifying undefined values like we did when we were simplifying. Okay, just a quick recall. If you were multiplying like 2/3 times 5/7, way back when, you multiply straight across. So we'd get 10/21, and that would be our answer. In that case, there's no simplifying to be done because 10/21 is as simple as it gets. It's the same concept when you're multiplying rationals with variables. So it's the same idea. We're still going to multiply straight across, but we are going to have to simplify, which means we're going to do our multiplication in 3 steps. Step number 1 is we are going to factor. Factor every part, both numerators and both denominators. All right, so we're going to start with this numerator. It's got 2 parts, and it's a linear term and a constant term. So we're going to be looking for a GCF here. So in this case, what divides out of x and 2? Well, just 1. So 1 times x plus 2. There is always a GCF, even if it's just 1. All right, now we're looking at the denominator of that same fraction. Again, we've got 2 terms, and one is a linear term and one's a constant term, so we're looking for another GCF. So what divides out of 3x and 12? Well, 3 divides out of 3x plus 12, and when I divide it out, 3x divided by 3 is just x, and 12 divided by 3 is 4 times. Now we move to our second fraction, the numerator. Again, 2 terms. It's a linear term and a constant, so we're looking for another GCF. So what divides out of x and 4? Just 1. 1 times x plus 4. And in our denominator, we only have 2 parts here. It's true, but this part is an x squared. So we could look for a GCF. In this case, the only GCF is 1. But because that's a squared, there's a new option that opens up here, and it's called difference of squares. If both parts, the x squared part and the constant part, are perfect squares, or another way of saying that is if they have a square root that's a normal something, not a decimal, then you have what's called difference of squares. And what you do is you take the square root of each part. So the square root of x squared is x, and the square root of 4 is 2, so we get x plus 2 and x minus 2. Difference of squares is one that gets missed frequently, so it's a good one to keep practicing. Anytime you have 2 terms and one of them is an x squared. And it won't always be just a regular x squared. It could be like 36x squared, because that also has a square root. Okay, so we factored everything. That was our first step. Second step is we're going to simplify, just like we did before. You can simplify anything from the top, cancels with anything from the bottom. What you cannot do is you can't cancel things top and bottom and bottom. So in this case, I look at my numerator up here, and I compare it to the denominator. And I say, okay, is there anything up there that matches anything down here? Well, sure. I have an x plus 2 in the numerator and an x plus 2 in the denominator. Those will cancel. Anything else? Well, sure, I have this x plus 4 and this x plus 4. Anything else? No, that's it. So all of those things are going to cancel out. But it still has to be a fraction. So my simplified version of my fraction, and we're going to do the last step at the same time, is to multiply. So we're going to take what's left, in this case 1 times 1 in our numerator, and we get 1 over. What's left is a 3 times x minus 2. And you don't need to multiply it back in, you can just leave it in factored form. In fact, please do leave it in factored form. Just like that. All right, when you're dividing, there's only one thing that we need to remember first. And it's the same when you're dividing normal fractions as it is when you're dividing fractions with variables. We have to flip the second fraction and multiply. So it's always the second fraction that gets flipped around, and it turns our problem from a division problem into a multiplication problem. So the first fraction, this one gets left alone. So we have x to the 5th minus 4x cubed over x squared minus x minus 2. That's my first fraction. It didn't change at all. I'm changing my problem into multiplication, and I'm going to flip my second fraction. X squared minus 1 over x to the 5th minus x to the 4th minus 2x cubed. Okay, now we're going to go through the same steps we did for our multiplication. So we are going to factor. Okay, starting with, I always start with my top left numerator. We've got two terms. They're not a difference of squares because I don't have an x squared or an x to the 4th. They're all odd numbers. So that means I'm looking for a GCF. So if I have x to the 5th, remember that's really x times x times x times x times x, right? I have 5 of those. And negative 4x cubed is really negative 4 times x times x times x. So I have 3 x's in common. So this is going to, I'm going to write my new factors down here. I'm going to have x cubed out front. What gets left behind is x squared minus 4. Hold up though. Didn't we just have x squared minus 4 up here? And it was a difference of squares. And it factored to be x plus 2x minus 2. This is a difference of squares. This particular fraction has 2 layers of factoring that needs to be done in my numerator. This is going to factor to be x cubed times x plus 2, x minus 2. Okay, so we factored our numerator. Got to factor our denominator. So we're done with that. This is a trinomial, but it's got a equals 1, which is handy. So we just need to know what multiplies to give us negative 2 and adds to give us negative 1. Well, that's going to be negative 2 times 1. So my denominator is going to be x minus 2 and x minus 1. Excuse me, plus 1. I am running out of space. That is one convenient thing about technology, is I can just move it over. Okay, so we factored our first fraction. Now we need to factor our second fraction. When we look to our numerator up here, we only have 2 terms. It's true. The only GCF there is 1, but we've got an x squared. Is this a difference of squares? X squared we know has a perfect square root. That's x times x. Is 1, does it have a square root? Well, sure, it's just 1 times 1. So our numerator here is a difference of squares. It's x plus 1 times x minus 1. Okay. Our denominator here has a lot going on. Part of the struggle here is that we have x to the 5th and x to the 4th and x to the 3rd. We have lots of high exponents. So just like we did with our first numerator over here, we're going to factor out a GCF to start. So the most number of x's I can take is x cubed, because I can't take more than 3 out of x cubed. So I'm going to take x cubed out. And that's going to leave me x squared minus x minus 2. Well, this is just, we just factored that, right? What multiplies to be negative 2 and adds to be negative 1? Didn't we just do that? That is negative 2 times 1. So this denominator has my x cubed, but then when I factor this part that's remaining, I get x minus 2 and x plus 1. Okay. Our second two steps are simplify and multiply. So we're going to simplify anything from the top can cancel with matching things from the bottom. So let's compare. What do you see in the numerator that can cancel with things in the denominator? Well, we've got this x cubed can cancel with that x cubed. We've got one of our x minus 2's can cancel with this one. You can't take both of them out of the denominator because we only have one in the numerator. Similarly, we can take one of our x plus 1's and cancel with this one. Can't take both of them, but it doesn't matter which one you do take. I think that's it. So anything left behind is going to be part of our answer. So we've got this x plus 2 and this x minus 1 in our numerator. You don't need to multiply them together, just leave it in factored form. And in our denominator, we have those two things, x minus 2 and x plus 1. So that would be our final answer.